All right. Well, good evening, everyone, and welcome for joining us. This is our live from LEAG. LEAG stands for the Lunar Exploration and Analysis Group. We're at the annual meeting here in Washington, D.C. Specifically, we're at the Washington Hilton. My name is Andy Shaner. I'll be your moderator this evening. I'm with the Lunar and Planetary Institute in Houston. And with me is my panel of distinguished scientists and engineers. So I'm going to go around real quick and just let them introduce themselves. So tell us who you are, your institution, what you do at your institution, and why do you participate in LEAG? So we'll start with you, Debra.
All right. I'm Dr. Debra Needham. I'm a NASA Marshall Space Flight Center in Huntsville, Alabama. I am a lunar scientist or planetary scientist, but I focus a lot of my time on the moon. And right now I'm, part of the initiative to get humans back to the surface of the moon. So we're really excited about the opportunities for exploration and science investigations that the lunar surface offers us. So that's why I'm here.
I'm Dr. Sarah Noble. I am a program scientist in the Planetary Science Division at NASA headquarters here in DC. I am a lunar geologist by training, and I both fund a lot of lunar research, as well as I am working on our next generation of lunar activities, including the commercial lunar payload services and various parts of developing a science strategy for Artemis.
Klaus, I'm a retired former Boeing employee. I have a visiting scientist appointment at the LPI. And with the LEAG, I've been involved with the LEAG probably since the first meeting. And specifically here now, I'm the chair of the LEAG's commercial advisory board. Yeah, what a commercial advisory board. And our job is really to try to field input from commerce, and specifically these days the CLIPS providers and the commercial launchers, and feed their input up back to the LEAG.
And I'm Kris Zacny. I'm VP at Honeybee Robotics. We make science possible. We develop instruments. We develop sampling systems for future missions. And the reason why we're here at LEAG is because it's a just superb venue where we meet top-notch scientists who want to go to the moon. They want to explore the moon, and they're asking tough questions, and we're trying to find out how to answer these tough questions. And then we go back to the drawing board, and we design systems and spacecrafts that can answer those questions. So it's just superb venue. It happens once a year. Unfortunately, hopefully it's going to be more than once a year. But it's been so far really good.
Thank you all. So what we want to do this evening is just I'll start off with a few questions for our panelists to just kind of get things rolling and discuss from their perspective what's happening here, or at least over the past couple of days at LEAG. There's one more day tomorrow, but then everybody skedaddles at the end of it. So we're doing it tonight instead. And so while we're talking, think about some questions that you might have about lunar science and exploration, especially the future of it, or what we're doing right now and preparing for it. And then type your questions in the chat box you see there on your screen, and we'll get to those and ask our panel those questions as they come up. So don't be shy. They're happy to answer anything you got. Yes, you are happy to answer anything they may ask you. You just may have to answer it.
We're here for it. It's good.
Yeah. Okay. Absolutely. So yesterday, the first day, a good chunk of the day was talking about this thing called a decadal survey and preparing for it. So this is in addition to some usual presentations in the morning from NASA folks with updates and various topics. But for those of us on the call listening that don't know what a decadal survey is, what is that and why is it important?
And everybody's staring at me. Yeah, I can answer that. Right, NASA headquarters. I can answer that. About every 10 years, each of the science. So NASA science is divided into 4 different categories: so planetary science, astrophysics, heliophysics, and earth science. And every 10 years, on their own schedules, each one of these divisions puts together a decadal survey, which gives them the priorities for the next 10 years. And these are complicated things to do, right? It's to get the entire community to sort of decide what it is you want to do for the next decade. And so it takes a couple of years to write this decadal survey. So our current decadal survey was published in 2013. So, actually we're not through our 10 years yet, but we're already starting to ramp up to do the work for the next one, because it's going to take a couple of years to actually do the study to figure out what it is we want to do for the next 10 years. And so yesterday's part of the meeting was about organizing this community to get ready to do that study. And the same sort of things are happening in all of our other assessment groups, the Venus group, the Mars group, Outer Planets, all of our various assessment groups are all doing the same sort of activity to get ourselves prepared for the decadal survey.
So to add to this, I've seen decadal survey going through, and what occurred to me is that it's a very much community input. So your voice matters, and more voices you have, you can essentially lobby for specific missions or specific priorities, which will be infused over the next decade. And being engineer and running a division at Honeybee, to us this is very important, because once we have a decadal survey lined up, then we can cherry pick technologies that we have to develop to make those missions actually feasible. So it's important obviously for science, but it's important for companies like us to get ready. So being part of League, again, we get a preview what the scientists dream about. Okay, what the scientists are dreaming about is gonna go into the new frontiers. So we can have heads sooner start than everyone else and get ready for those.
Yeah, I would like to add to that. In the past, the decadal surveys would result in a list of candidate missions for the next 10 years that us in industry would use kind of as our reference material for the kind of missions that we wanted to go out and chase. So, and those missions were quite expensive. 750 million, I think, was the cost.
So we have different categories of missions. Right. So in planetary, it's different in different divisions, but in planetary there are 3 categories of missions, right? So there's the big ones, things like Cassini and Galileo, right, that we send maybe once a decade, that we call flagship missions, right? So decadal will probably give you an idea of 1 or 2 of the next flagship missions. What is the big thing, right? And then we have a category called New Frontiers, which are sort of roughly $1 billion missions. They're not small. They're big missions. But they're proposed as a PI, a principal investigator, will come up with an idea for a mission and propose it. But they aren't starting from scratch. We put in the decadal every year, there's a list of like 5 to 7 destinations, kinds of missions that are options for New Frontiers. And then the third category is the smaller one, is a discovery mission. And those are wide open. We don't put any priorities in the decadal for that. Anybody who wants to propose a mission anywhere to do anything, if they fit under the cost cap, can propose, right? But then in addition to all of those things, the decadal also includes our science priorities. So it's not just a list of missions. Right. It's also a discussion of what is the science, the kinds of research that the community wants to do over the next decade, and what kind of technology investments do we need over the next decade. So it's a fairly comprehensive document. Yes,
it is. So thank you for all your points on that. So what I noticed looking at, so what happened yesterday late in the morning and then in the early afternoon, everyone here at the meeting broke up into different topics like geology hazards and resources for exploration and just these different topics. And then they came back together. And when they were in those groups first, they were talking about, what might be some new goals, or what are the current goals, or state of knowledge on those different topics, to then think about what they want to put in the next decadal. And one thing I noticed is that when everybody came back, there didn't really seem to be a lot of, I should say before Monday, League had been asked by the Planetary Science Division at NASA to come up with some questions. Some big picture type questions. And none of them specifically had the word moon in it. They all seem very broad for the entire solar system. I know that's on purpose.
Yes.
So would you like to explain why that is, though? Why ask League for questions if you're going to be talking about the whole solar system?
Right. So there's two parts to that. One is the way that we set up decadals, right? In the past, the ways that Planetary has set up decadal is they've split it into committees, and the committees have been based on targets. So there was a committee for Mars, there was a committee for outer planets, there was a committee for the other terrestrial planets. And we're thinking that it might be better, rather than focusing on individual planets, it might be better to focus on questions, right? What are the things that we're trying to answer that cut across these different planets? And so the headquarters has asked all of the advisory groups to think about these questions, and what are the questions that we should be asking, and how could we divide this up by questions. But in particular for the moon, right, it turns out that the moon is a great place to answer a lot of fundamental questions about the solar system. We call it the cornerstone of the solar system, because it's very close, and it's very easy to answer a lot of our big picture questions about other places in the solar system by going to the moon. It's much cheaper and easier to get to than a lot of those other places. So there's both of those things.
Yeah. You just want to add anything?
Yeah, I'll add to it. So in addition to that, we're also only one member of a much larger community. So not only, when we're here at League, we're talking to a bunch of other people who are really interested in the moon, and we all know fundamentally that there are a lot of fundamental questions that we can answer, decadal level questions, science questions that we can answer by going to the moon. But when we're in the room here, we're talking to other people who believe that. So we're preaching to the choir, kind of, in some respects. So one of the challenges that we face is also convincing the broader community and the public as well that we're actually right. We actually have something. Yeah, the moon is really important, and it's an intriguing destination in its own right. It's not a stepping stone to wherever we're going. It is a cornerstone to the solar system, to understanding. It is the linchpin for how we currently know the ages, the model ages of other surfaces in the solar system and the inner solar system are all based on the moon, because that's the place we have samples where we know the context where those samples came from. And that's just one example, but by understanding better and answering some of these fundamental questions that we have about the moon, we're also answering fundamental questions about other planets throughout the solar system. And so here it's an echo chamber, but we really want to convince the rest of the community that that's true. And so putting the moon in the broader context by not saying, oh, we can answer this question at the moon, but we can answer this really fundamental big picture question by, yes, going to the moon, but you're going to care about this if you study Mars. You're going to care about this if you study Europa or Enceladus, because that's our mission as a lunar community right now, is convincing the broader community that that's the case. And other communities are doing the same thing.
That's right. And, although everybody this week who's here has their lunar hat on, many of them also wear other hats, right? Most scientists who study the moon also study other things, right? Absolutely. Mercury, Mars, small bodies, right? So there are very few people in our community who have one body and only one body that they study.
That's absolutely right.
Yes, thank you. So we have a question already. Let's scroll back up here to it. So I've always wanted to know, how do scientists get more, quote, clout at decadals to get their own science more attention? Is it just how many papers you've published, networking, campaigning? When we talk to students about science, we want them to hear about authentic science. So what does that look like at a decadal. And if you could all just say your name again when you start talking.
Yeah.
Sure. So, Sarah, one of the main ways that the actual decadal committee is set up by the national academies, and you can nominate yourself to be a member of that committee. You can have other people nominate you as well, but the national academies decides who is on that committee and subcommittees, and they try very hard to get a sort of balance of people across topics and knowledge, but as well as across types of institute that they work for, types, gender and race and all of those sorts of diversity things, right? So they tried very hard to get a nice, good setup of a committee, but there's a limited number of people you can have on these committees, and it doesn't cover everyone. And so the main way that they get input to do these decadals is through what we call white papers, where anybody in the community can, write a paper, 5-page paper or whatever, about whatever topic they're interested in. You can get groups of people together to write them. You can write one on your own if you want about, whatever topic you're interested in, whether it's a mission you're thinking about or a particular kind of science that you want to advocate for. And hundreds and hundreds of these white papers will feed into the decadal. And so there's an opportunity for anybody to have a voice.
Just to add to this, this is Kris. Those white papers can be co-signed by 100 people if they believe in your mission profile or science questions which you want to answer. So it's not just your name. And the more people you have on the white paper, obviously it carries more weight with it.
Yeah, and this is Debra. The other thing I'll say, and this is particularly directed at the young people on the line, the language that you use in these papers is really critical. The writing itself is, you have to have a message that you're submitting and that you're championing, and you have to be clear and concise. And 5 to 7 pages is really not very much space to pour your passion about this subject onto the paper and convince the committee that your passion is more than just you. It is the community of all the co-signed and the endorsers that are supporting your mission and your ideas. So the creative writing, or it's not really creative writing, it could be creative writing, but the technical writing part of it is actually really important, getting a clear message across. So focus on writing. It's really important. It's really important. Really important.
Well, this is Kurt. Some of that question sounded a little bit like process. Like if I were to submit 20 papers, would I have more clout than? I thought I heard that. And so I'm not on the individual case, but say a target gets more papers than another. Is that influence? Say the moon gets 10 papers, Venus gets 20.
Yeah, so I was around the last decadal we did. I've been around a while. I was around for the last decadal, and there was particularly I remember between the Moon and Mars community about like how many papers they put in, or like, oh, we put in 2 more papers than you. So and really it's quality over quantity, right? The committee is going to read all of the papers, whether they get 600 or 1,000, they're going to read all of them. And they're probably happier with 600 good papers than 1,000 that are not, right? So I think it goes back to what Debra was saying about the quality of the writing. I think is probably more important than the quantity. It's not a numbers game.
I think this very thing was talked about yesterday morning.
Yes, it was.
And the National Academy person said the same thing.
Yeah, yes.
She did. Right on message.
So some of the things that I believe, Sarah, and tell me if this is Kris, by the way, if I'm wrong, but I think it seems like for the first time NASA actually funded 11 planetary decadal studies. And so they kickstarted this entire process by asking community to propose their favorite missions. And just recently, probably last week or 2 weeks ago, NASA selected 11 of those mission architectures, and those will receive some funding. And over the next something like 9 months, these groups will be putting together reports, what they find, and those reports will make their way into the decadal. So it's another way that the decadal survey can be contributed to.
Yeah, that's an experiment we're trying new for the first time. The Decadal will always do sort of mission studies like these, and the problem is that we only have 3 places who can do these kinds of studies: JPL, APL, and Goddard.
Right.
So, and they were getting backed up, right? Like, this is a 2-year process, but like 2 years is a finite amount of time. And so we decided to kickstart the process by starting these 11 discussions early. The Decadal, the committee will still have more money to put up more selections. So, all the folks who didn't get selected in this round, and there were 54 proposals that went in, and we only picked 11 of them. So there's plenty of more ideas for good missions out there. Those people can write white papers, and perhaps then in the second set of these, they will still have an opportunity to do that kind of research. So it's not you're in or you're out. There are more venues, right? So it's just a way to kickstart.
So this is Kris again. Sarah mentioned the 3 different mission types: discovery at $500 million, new frontiers at $1 billion, which are competed missions. And specifically, new frontiers, there's number of targets, around 5 to 7 targets every 5 years. You have 2 new frontiers per decade. But as part of a decadal survey, the decadal committee essentially has a strawman architectures, but science is really good for all of them, but they have no idea whether, based on a cost, those mission architectures will fit into the new frontiers $1 billion cap. At that point, they go to JPL, they go to Goddard, APL, Aerospace Corporation, and these sort of independent teams, they put together a group of people. They come up with the strawman payloads and a mission, and they select launch vehicle and things like this, trying to figure out whether at a high level this mission would cost $1 billion or $2 billion or $500 million. And this information goes back to the decadal survey, and at that point, the team makes a final selection, which of the mission profiles, whether it's a sample return mission from the moon or exploration of Titan, which of those actually make it into the final decadal survey.
Okay, thank you. And we have another question, which actually kind of helps lead into our kind of the next thing I want to talk about, which was today in the meeting. There was more talking about return to the moon with Artemis, but also the robotic exploration that will precede that. ISRU, or the in situ resource utilization discussions, and also talking about commercial space. Groups like Astrobotic, Intuitive Machines, Orbit Beyond, which you may not have heard about. You've heard of SpaceX, and you've probably heard of Blue Origins, but these are specifically 3 companies that will be putting things on the moon for us. Two of them. 2. We're putting things on the moon for us. But so the question that came to us from the audience is, so our asker does not personally believe this, but they've heard from audiences that some people consider Artemis and exploring the moon further as a distraction and an actual delay from deeper exploration to Mars and beyond. So how would you have an educator respond to a statement like that, or anybody to respond to something like that? And I think we've kind of already said that, but
sure. So this is it's like passing the buck.
Everybody can't wait to jump on this one.
Yeah. So this is Debra. So first of all, I want to say that going back to the moon is it sounds like we've been there and we've done that because we've landed there, but we've been to a very small portion of the moon. It would be like going to, Connecticut and saying that everything there is to know about all of Earth. And the moon is a diverse and intriguing place, and like we said earlier, can answer some of the fundamental science questions that we still have about the origin of the solar system, origin of planets, the origin of the Earth, and when life began on Earth, and what the environment was like when that happened. that evidence is erased on Earth. We don't have the rocks that we can go to characterize what the environment was like, but on the moon, it's still there. So going to the moon and exploring different areas, including the South Polar region of the moon, can really lead us to insights about how we started on Earth that we couldn't otherwise get. So the moon is an interesting destination in its own right. On top of that, there are technologies and capabilities and operations in space that we need to basically practice. I mean, you want to test some equipment in your backyard before you go off to Antarctica and the extreme environments and to use that equipment for the first time. So you want to test this out in your backyard before you go. And the moon, it offers that opportunity. We can perform some really complex missions on the lunar surface that we've never done before in preparation for going farther into the solar system, to Mars, sending humans to Mars. So we can learn a lot about how humans operate for long durations in deep space beyond the protective environment around the moon, around the Earth, where ISS currently resides. Send humans farther out for longer periods of time and conduct complex surface operations like they would conduct on Mars. So those are the kinds of, it's a proving ground, a stepping stone, yes. So it's a destination in its own right, but it's also a stepping stone for deeper space exploration.
So I would add to that with the prospect of prospecting for resources and for production of those resources through ISR, what's called ISR, in situ resource utilization. We have the opportunity to resupply our spaceships and our crews from resources from the moon without bringing that stuff all the way from Earth and the gravity well from Earth. So it should be much less expensive once it's been proven that it's there and that we can mine it and use it. And
This is Kris. I want to add another point. It's tourism. I firmly believe that technology is going to improve. Technology is going to get less and less expensive. And maybe not in 10, but maybe in 20 or 30 years, you will be able to take your vacation on the moon. It's a couple of days away. You can hang out for a couple of days and you can come back. Yes, it's not going to be for everyone, but there will be individuals that would love to do that. And although this is not priority right now, some of this may come out of going back to the moon. Essentially, there's going to be a new industry, space tourism, that will take people to the moon. I really believe that that's going to happen sooner or later. It's just like it's happening right now with Virgin Galactic and Blue Origin, flying people to the suborbital flights. It's just a matter of time.
Okay, thank you. Good question. So, like I mentioned, we a lot of us have heard of SpaceX, and especially with their rockets that can land themselves, even on floating barges out in the ocean. But those are rockets. Those are things that can help get us to the moon. But what about when we actually want to set down on it, whether it's with astronauts or just robotics? And there's 2 companies here this week that will be doing that in a couple of years. So why are they here at League? Why are those 2 companies here?
I can take a stab at that, but those companies are primarily engineers, and they know how to build things. They don't necessarily, I think it's safe to say, they don't really understand what the scientists want to do or what their payloads do. And so one of the big things they're here for is to get that kind of education. And I've talked to a number of them tonight. We had all but one of the commercial lunar payload service CLIPS providers here, and they all found that dialogue to be invaluable.
this is Kris. The scientists here at the League are essentially customers for payloads that will go to the moon. So it sort of makes sense for them to meet the future customers and figure out what's in the pipeline. What sort of instruments they want to fly, whether they're going to be big, whether they're going to be small, and they can develop technologies, they can develop certain capabilities to address future calls for proposals. That's number one. Number two is sometimes they coming here to ask certain questions about the moon. Questions like regolith. Different parts of the moon have different regolith, and regolith is a soil. It's planetary soil. It can range from microns or submicron in size all the way to actually big boulders. But it's we call it regolith, a soil that has not seen water. Actually, yeah, because on Mars you have regolith. So
I think it's soil created through impacts.
The impacts, but so you have Martian soil, not Martian regolith, right? Because it's in a water alteration and so on. So regolith you have on asteroids, regolith you have on the moon, but you don't have regolith on Mars because it's been processed by water. But questions like what's the particle size distribution this regolith has, and can it actually damage a spacecraft upon landing? Can it do a self-blasting when rocket engine blows the regolith away? All of these questions can be answered by asking some of the folks within the audience here at the League. In addition, the spacecraft could potentially alter parts of the moon. The parts of the moon where scientists would like to, make measurements. So these sort of discussions between scientists and engineers will solve the problem. Whether flying hydrazine to the moon with the rocket engine and spraying ammonia on the surface is going to affect future measurements. Those sort of things can be addressed here, especially in the evening, sitting in a bar and thinking big thoughts.
Dreaming big, always dreaming big.
Yeah.
Yeah, so those of you who are out there listening to this, please, if you have any questions, feel free to type it there in the chat box, and we'll get to it, and we'll get you an answer. I think I see. Okay, here's something. Okay, here we go. The general public lumps together science and engineering, and I've met many students who have a bad experience with one or the other, so then they dismiss the whole STEM field. What are some strategies, perhaps from your own experience, on how educators can overcome or differentiate STEM fields for those students who have soured on all of them?
Wow.
Wow.
So I can just tell a little of my own personal story. I was educated as a scientist, but I worked for one of the world's largest engineering companies. And scientists and engineers, they have different vocabularies, and they care about different things. I don't know if it's an answer to your question, but a multidisciplinary approach to education and to life in the workplace is a really good thing. To maybe not necessarily. Well, you have to specialize at some point, or you just become a generalist. But I don't know what age your students are, but certainly in high school, a broad education is probably better than having a really fine point on things.
So I started out as an engineering major in college and realized I did not like engineering and switched to science. And I always defined it as engineers are interested in how and scientists are interested in why.
From my viewpoint, it takes a village. It's not just scientists, it's not just engineers to pull off big missions. It takes different skill set, including folks like finance, including project managers and program managers, and including machinists. It's just a big programs require different skill sets. So you don't necessarily need to be a scientist or engineer to be involved in planetary missions. As long if you like planetary missions, there's going to be a skill set that will fit what you're interested in.
I think that's absolutely true. This is Debra again. I would add to that, artists are needed too. I mean,
communication specialists,
yes,
and education specialists, and
public relations. I mean, it really does take a village to do this, to do what we do. So all skill sets are needed, and I think there is a lot of overlap, and you do have to talk to each other. And
we actually have people who specialize in being able to communicate, to translate between scientists and engineers.
Yes.
There are people who spend their entire career doing nothing but trying to translate from scientists to engineers. It's very important.
Sometimes keyword is trying.
Well, and that's this thing of translating between disciplines came up today in talking about the in situ resource utilization and talking to mining companies. Because even though if engineers that work for mining companies, they don't necessarily speak the same language as engineers in the space industry. So even amongst that discipline of engineering, there can be some needing to figure out how to speak the same language. So it doesn't get any easier after you become a student necessarily to graduate. It's just another issue.
Well, that's kind of the thing about being a scientist and an engineer too. I mean, you're always learning something new. You almost never really stop being a student in some respects. I mean, you start, defining your own projects and everything, but still, it's you're always learning something, and to be open to that knowledge, you're never going to know everything. And every time you find maybe an answer to part of your question, inevitably there are going to be 10 more questions that you come up with, and so that's part of the exploration world, I guess, and mindset is you never stop exploring, you never stop learning.
Well, and something that's been said a lot over, oh my gosh, the past decade, it seems to come up in like every other sentence the past couple of days, is that science enables exploration and exploration enables science, or vice versa. So they go hand in hand. It's kind of hard to have one without the other. Yeah. So thinking about the things that were discussed today, the Viper, for example, this new rover mission to go to the moon, and the mission and instrument concept posters that are out here in the hallway, and these ideas that people have for future missions. What was the most interesting thing to you, or what excites you the most about what could be happening in the future with lunar exploration?
There are two words that I heard consistently here for maybe the first time. One was prospecting. I haven't really heard NASA talk in those terms until this meeting, and that was good to hear, because it started to sound to me like they really were understanding why it was that way. And the other one was a campaign of missions, where it's not just a single lander or robot doing one thing, but a campaign for things like sample return, prospecting, and lunar network. Those were all campaign candidates. Maybe there are others, but now I don't know how we're going to do that. But if we can figure out a way, that's going to be great opportunity for the commercial guys, because a lot of that can be done for fairly low cost.
This is Kris. To me, the most exciting thing is that robotic exploration comes hand in hand with human exploration. This is something that doesn't normally happen. You either send humans or you send robots, but here it's sort of the first time where we see the parallel paths where robots go in and do just tremendous science exploration, and humans go in and they take advantage of this and they progress even further. And as we look at the cadence of those missions, there is no end to it. So robotics doesn't stop, and human exploration doesn't stop. They feed from each other to get more and more knowledge. So that's really exciting.
This is Sarah. What's exciting to me, tonight's poster session featured a lot of instruments, right? And they're not just ideas. They're things that we've selected and are funding that we are going to send to the moon. We're not just talking about potential future missions anymore. This is things that we are actually building. Kris, 2 of them are yours, right?
Yes, that's right.
that we're actually building and preparing to send to the moon, to the surface of the moon, where we have not been in almost 50 years, to the surface of the moon. And I mean, you can feel the excitement in the community about the fact that this stuff is real and not just sort of potential nebulous future things, but like hard concrete things that we are sending.
Yes, I need to pinch myself every so often. One of the things that
I had to make him pull over when I told him to tell him he was driving. Pull over.
I was driving to pick up my kid, so I was late to pick up my kid.
You have 2 more kids now.
I've got 2 more kids now. But we're flying something called PlanetVac. It's a pneumatic sample delivery system. And this idea has been in works for almost 2 decades. So it just shows how much effort it takes to get to a point where it's ready to fly. And also, right now we have opportunities to fly. Those opportunities weren't there a decade ago. And stars line up. And this offers folks like myself and many others to essentially turn the ideas and technologies they've been developing for decades to actually go somewhere. And I talked to some of the other PEIs who have been selected, and they go, "This is a dream come true." Some of them are towards the end of their careers, and they go, "This is the best thing that has happened to me. I'm going to the moon." And the cadence of Eclipse missions allow more entry-level scientists to dip their toes into developing instruments for the planetary exploration. And it's also one way to educate future scientists to become principal investigators for big missions. So it's a win-win across the road. Yeah.
If I jump in for 1 second, so that was the second time CLIPS has been said. Now that's an acronym. So real quickly, what is CLIPS? What is that?
Commercial Lunar Payload Services. Oh, you mean what is
this is a program that NASA has to procure services to deliver things to the moon for us. So a lot of these companies, a lot of them were former Google Lunar X Prize participants, whatever. We talked earlier about Astrobotic and
Master.
Yeah. Anyway, a number of these companies who started their life as Google Lunar X Prize, none of them won, but they're out there, whatever, and are now capable of getting to the moon. And so we are using these companies to procure services. So basically like FedEx or DHL, Astrobotic always wants me to say. So we are paying them to send our payloads to the moon, right? Rather than having NASA build their own spaceships and landers to get to the moon, we're just paying them a fee per kilogram to bring our payloads to the moon.
It's sort of what SpaceX and Orbital are doing right now. NASA pays them to send a cargo to ISS. So we know that this sort of incentive works. It was proven for launch vehicle providers. So now why not trying it for the providing of payloads to the moon?
Okay. Yeah, and I guess this is Debra. I get my most exciting moment for LEAD this year. It's kind of touching on things that have already been said, but I think for me, it's the future is bright. I mean, we have some really exciting plans to to explore the moon and explore the solar system, both robotically and with crew. And like Kris said, it's not one or the other, it's both. And like Sarah said, this is happening. I mean, it's actually happening. And I mean, I'm relatively early in my career, but it's really exciting times to be doing what we're doing and to share that excitement within the lunar community, but beyond that with you and the public. And just, it's really infectious in the best way possible. The excitement here is just, it's pervasive and it's real, and we're really excited about what the future is.
And I think this is, Andy, not that anybody cares, but I think I think a lot of the excitement has to do with that. We talked about Apollo for so long because it's kind of all we knew. But now, most of the Apollo folks are retired, right? And they're not really in the game anymore. They advise, they help and do stuff, and it's always great to talk to them. But now there's this whole new generation with a range of ages that didn't really experience Apollo in the same way. So now you're getting to, right?
Yeah.
And so I think that's great.
Well, one thing I want to mention, and that's Kris again. Most of us here in the room, they've been doing it for a long time. I've been doing it space for almost 2 decades. And honestly, I haven't seen anything like what we're seeing right now. We're seeing private companies, and we're seeing very wealthy individuals investing their own money to go to the moon. But one thing worth mentioning is all of those teams, they've been selected through so-called private-public partnerships. And that's an important one because this means it's not just NASA giving money. Private companies are also providing funding to some level to actually go to the moon. So they have a skin in the game. It's not just paid for hire. They actually want to do this for real. We see Blue Origin, that has been a company, for over a decade now. Jeff Bezos founded the company, and he's really serious about going to the moon. Elon Musk is really serious about going to Mars, and they have funding behind the name. So things are different. Things are different, and I think we reached this win-win partnership where NASA working with private industry, having the same vision, will be successful. That's why there is no end to it. We don't see end to it.
All right. We got another question online. In your own personal opinion, so not necessarily reflecting NASA Marshall, NASA headquarters, LPI, or Honeybee Robotics, how confident are you about the timeline that NASA has laid out for humans on the moon by 2024? So scale of 1 will be delayed, scale of 10 definitely on time. If you want to just hold up a finger and I will just tell you what the numbers are, that way it's not attached to any name.
I came here being fairly cynical about that timeline until I heard what NASA had to say today, and it became a lot more real. They're using the right language, and if the will of the nation, carries out that this is something we really want to do, and it survives a change in administration, I think it might be doable. It might be dicey, but it might be doable.
So that's Kris here again. I did like personality profile before, and I was told I'm unrealistically positive. And I don't know whether it's a good thing or bad thing. But I think we can pull it off. And I think we can pull it off because of the people involved in putting this together. And the people, they work really hard. They come up with ingenious solutions to cut down the schedule and cost. And if there is a will, there is a way. I think it's also very, very important to put aggressive schedules, because aggressive schedules motivate people and reduce waste. If we were to be going to the moon in 2034, everyone would say, "Oh, we have plenty of time. Let's just think about how to do this and do another study and things like that." And before you know it, you could potentially waste a lot of money. But if you have to be on the moon by 2024, you have to be razor sharp, have focused vision, do the trade study very quickly, cut metal, and go with this. So it motivates people to get things done.
Okay, thank you. I think if you pulled everybody here that's at the meeting, you would probably get a spectrum of answers to that question from 1 to 10. So, but we just have to wait and see, right? Everybody gets to do is we all get to wait and see. So just about 10 more minutes left, and we just had another question pop up. But I want to just put this closing question out to you four, and you can just kind of think about it. And we'll get to this question, and then we'll get to this one to close it out. So there's just one more day of the meeting, which is tomorrow. It's just in the morning. And it'll be looking, my understanding, kind of towards, so what do we do after Artemis, or what happens in the future? That's tomorrow. But considering what's happened the past couple of days, or just in general, what is one thing you would want to tell people out there, folks out there, to be looking for over the next couple of years in terms of lunar exploration? What should they be paying attention to?
You want us to answer that now?
Not right now.
Yeah.
Just think about it. Think about it. So while you're thinking about it, I'm going to throw another question at you. We have two hemispheres.
Parallel processing.
So this is a question about the Viper rover. So some elaboration on like who's building it, who's managing it, who's sending it, delivering it. What's Viper? What's it all about?
So the payload is based on a number of instruments that we've been studying for quite a while. Its goal is to explore, prospect the volatiles that we know exist at the poles, figure out where they are, how deep they are, how much is there, is it something that will be valuable as a resource, what can we learn about it from a science perspective. So it's a very synergistic science and exploration kind of mission. And we've been wanting to send a mission like this for a while, so we've been studying instruments to do that for a long time. So we have a good payload. The rover is being built by JSC.
Yes,
I think that's right.
Yes.
Yeah.
And the lander will be a CLIPS lander. Right now, most of the CLIPS companies, it requires a bigger rover, a bigger lander than most of them currently have. And so we have recently put out a call to see if there are other companies out there that are more interested in building bigger landers. And so we're about to make that announcement that there will be more companies. And then we'll put out a request to all of the companies, the current 9 plus whichever new ones get added, to see if any of them are interested in building the lander. And we'll pick one of them to build the lander for us. So we don't yet know who is going to build the lander yet. But.
So to add to what Sarah mentioned, the rover itself is going to be around 500-pound rover. So smaller than Curiosity, but bigger, significantly bigger than Mars exploration rovers. It will have neutron spectrometry in the front to sniff for hydrogen, which is a proxy for water. And once we find the water, at that point, it also has a 1 meter drill system that will be used. It's actually my company's providing this, Honeybee Robotics. And it's going to drill down to up to 1 meter depth and expose volatile-rich soil on the surface. And another 2 instruments will look at those volatile-rich soil. The first one is NERVAS. It's a near-infrared spectrometer. The PI is Tony Colquitt. And then it has also mass spectrometer. The PI is Jenny Captain from Kennedy. The rover is gonna drive around or traverse for around 100 days. So it has some survival capabilities to go on for 100 days. But, I think if it survives 100 days, it's going to go for way longer than 100 days.
So it'll be solar powered, right?
Yeah.
And it's going to be, hanging out at the poles, right? And one of the advantages of the poles, one of the reasons we're interested in the poles, is that there are places where you get sunlight, right? Most of the moon, you get 2 weeks of sunlight and then 2 weeks of night.
Right.
And that's really hard to do with the solar powered thing, to survive 2 weeks of night. It gets very, very cold. It's really hard to survive. But there are places at the poles where, especially if you're a rover and you can move around, right? You can sort of follow the sun and stay in the sunlight. And so that is the plan to do with this rover, is to try and stay in the sunlight as much as they can to last through several lunar cycles. But it will be capable of going into tipping at the toe into some of these permanently shadowed areas where we think the volatiles are located. So it will take short dips into darkness, but hopefully stay in the light enough to keep going.
So here's a quick question. So with Mars missions, they operate on sols, right?
Yes.
So Sol 1, Sol 2, that's like the day of the mission. What kind of units of time are we going to be talking about with lunar mission?
I mean, we call it, we say lunar day, lunar night, right? But it mostly, we're still mostly talking about, 2 weeks, right? We say, oh, a lunar day, or 2 weeks, and then.
But you're right, because even in fall, lunar day could be many, many days.
Right.
It's always lunar day, right? And then there is places where you have always lunar night.
Right.
That's a tricky one.
I don't think
it's going to be Earth
we
time.
really thought about it yet.
That's probably the last thing to worry about, but I was just curious. All right, so we got just a few minutes left. So the question I want to wrap up with is just if there was one thing you could tell folks to be looking for, which could be a mission or something in the next couple of years, to kind of keep their eye on the horizon and looking forward, not just looking at what's happening today or what's not happening today. What is something you would like people to be aware of that they can follow over the next couple of years?
So I think that the fact is that we are landing on the moon soon, right, with these robotic missions. So the first two are going in 2021. It's not that far out, right? And then Viper in 2022. So there is going to be a regular cadence of us landing on the moon. Our anticipation is that there will be 2 of these CLIPS missions every year starting in 2021 and going forward. So there will be lots of opportunities to watch things land on the moon.
You have the same answer.
There is nothing more exciting than going to the moon. So watch out for 2021. First CLIPS, and then second round of CLIPS and Viper, and then humans. It's just exciting times.
Yeah, and as much as I absolutely love talking about lunar exploration, there are other things that are happening in planetary science. In 2020, July of 2020, I believe, Mars 2020 rover is going to be launching from Cape Kennedy. So that is also something to look out for. While the moon is an intriguing destination in its own right, it is not the only destination out there. So there are exciting times ahead for planetary
We're
science.
also soon coming up on the sampling of the Bennu asteroid that OSIRIS-REx is visiting.
That's right, and those samples will return in 23, I think. 2023?
No, it's later.
Is it
later?
Yeah.
Okay.
I can't remember how long it takes. It takes a while to get them home.
Yeah, so that's really exciting. And that's going to be some primitive material that mission's actually going to bring back to Earth in some time frame that we will confirm. So that's another one. And
Hayabusa 2.
Hayabusa 2 has already sampled and it's on its way back.
Well, okay, Europa Clipper is pretty exciting. I don't know when that is launching,
That's in
but that's
planning,
It's
24?
still a couple of years
Yeah.
out. Yeah. Psyche, the other mission that I'm working on, is launching towards the asteroid Psyche in 20. No, it's 22. I think it's December of 2022. And Lucy is launching in 21, isn't it?
Yeah.